GCSE rates of change and graphs. Variable acceleration. Let's take a look. We're going to address all the types of questions they can ask you for variable rates of change. So variable acceleration, that kind of stuff. Anyway, I'm yapping. Here is a speed time graph for a train. Here we can see the time in seconds and its speed in meters per second. And you can see gradually it's getting faster and faster and faster, which means its acceleration is varying. It's getting quicker and quicker and quicker because it's getting steeper. Work out an estimate for the distance traveled in the first 20 seconds using 4 strips of equal width. Now, how do you calculate the distance traveled in a speed time graph? Well, all it is the area underneath the graph within that time period. Why is that? We know that distance is speed times time, right? And if I give you guys a different example of a train, where this is your time and this is your speed, if the train was traveling at a constant speed of, say, 5 meters per second for 10 seconds, okay, if it was traveling at 5 meters per second for 10 seconds, you would multiply them together to say that it had traveled 50 meters. Now on a graph, all you're doing is you're finding the area of this rectangle, the base length times the height. Okay, so the area underneath the curve or line in a speed time graph gives you the distance traveled. Now the issue we have in our question is that it's a curve. And how do we work out the area under a curve? Well, we can't unless we're doing A-levels and we know the equation of this curve. So what they're doing is they're saying to use 4 strips of equal width, meaning form shapes that can estimate the area. And for that we use trapezia. Yeah, so trapeziums and triangles. So what we do, we're going to work out the area between 0 and 20. We're going to draw vertical lines upwards. Like this. Now obviously in the exam you'll have nice graph paper. And then we connect. So point to point, point to point. Like this. Now can you see these trapeziums that I'm drawing are very close to the line, but they're just a bit slightly above. Because the graph is curving outwards, we would say that's a convex shape. If you do physics, convex means that all of these strips are lying above the curve. If it was the other way around, then they would lie below. Okay. So we're going to work out the areas of these 4 shapes. So area 1, 2, 3, and 4. Now the first one, can you see it starts at 0? It means it's a triangle. So area 1 is a half times the base length. Now the base length is 5 times the height. And now this is where on your graph paper you guys are going to read across. Now to me, I'm going to say that's 2. Okay. I'm doing that tactically because half of 2 is 1 and then we get 5. Okay. A2. Now here we have a trapezium. So the area of a trapezium is a half h. Now h in our case is still 5 because it's a half h a plus b. And your a's and b's are the parallel sides. So here are your parallel sides and h is the distance between them. So it's a half of 5 times the addition of the parallel sides. Now I already know what this height is. It's 2. We said that before, right? So 2 plus, what's that height? It looks like 5 to me. Actually, it's slightly below. So I'm going to be cheeky here and say it's 4. Because I'm going to make the numbers work out, so I don't need to work with decimals. And I made this question up, so I can do our 1 in it. 2 plus 4, 6. Half of 6, 3. Times 5, 15. Okay, double checking. 6, half, 3, yeah, 15. A3, half h, still the same. All the strips have equal width. 5, 5, 5, 5. Then, first height I said was 4, plus that second height. What should we say that is? 8. I'm going to say that's 8. 4 plus 8, 12. Half of that, 6. 6 times 5, 30. Double checking. 12. Half, 6 times 5, 30. A4. Half h I already said this height here was 8. Then this height here, 12. 8 plus 12, 20. Half, 10 times 5, 50. Now we add them up to get our total estimated distance traveled, which is 20, 50, 100 meters. You traveled 100 meters in the first 20 seconds. Part B. Is your answer to part A an under or over estimate? So what we said before is that the strips lie above the curve. Because the strips lie above the curve, it's an overestimate. It's bigger than what the actual area is because the curve is actually slightly below and its area would be smaller. So we're going to say strips lie above curve, therefore overestimate. Okay? They do usually say give a reason for your answer. You can't just say over and under where you have a 50% chance of getting it right if you just guess. Then it says estimate the acceleration of the train at 15 seconds. Now, in a speed time graph, how do you calculate the acceleration? Well, the acceleration measures the rate of change of the speed. So how is the speed changing over time? To measure how something is changing, that's to do with the gradient. So at t is 15, we need to somehow measure its gradient. Well, how do we measure the gradient of a curve? Because with a line, it's simple. We just do change in y over the change in x, right? Well, here's the theory. The rate of change, so the gradient of a curve at a particular point, is equal to the gradient of the tangent of the curve at that point. Meaning, we need to draw a tangent here, a straight line that just touches the curve here at one point, and then we'll estimate the gradient of that tangent. That's why it's an estimate, because it's not exact, right? Everybody's tangent is going to look slightly different. So I'm going to do my best here. I'm also going to use a thinner pen. Maybe I'll use blue. Let me just double check it works. It does. So what I'm going to do is I'm going to use this ruler that I found in the bin, and I'm going to estimate. Maybe I'll do this. All right, so the way you want to do it is you want to get an equal amount of gap on either side. Okay, so look at something like that maybe. All right, so I'm mainly showing you guys the technique here because everyone's answer is going to look slightly different. But one way you could do it is you could connect these up and kind of follow along. It's not always going to work here. I don't think that works very well, but that's always one way that you can get to a decent solution. So here, you kind of go until you don't see any more. Here, I would probably need to rotate a little bit more this way. And I'm going to draw my tangent. It's got like a weird hinge here. Okay. What do you guys think of that? Okay. What do you guys think of that? It looks beautiful to me, mate. Now, what we do now is we find 2 points and we work out the gradient. Okay. Now, I already know what one of the points is. One of the points here is 15. And what was that one again? I think I said that was, what did I say that one was? 8. 15, 8. I said that one was. I just need to find something else. Now, obviously, guys, I don't have a proper grid here. So I'm going to find a nice value. I'm going to say, I'd rather divide by 4, I can't lie. So I'm going to do 19. So 19 is about here. 19. And going across, beautiful 10. Okay, it looks like 10 to me. So now we're going to work out the change in y with the change in x. Now here we can clearly see that my change in y here, my change in x, sorry, is 4 to go from 15 to 19. And we're going up by 2. Okay, so my answer to part C, which I've lost all my pen lids, my acceleration is about my change in y, 2, divided by my change in x, 4, which is 0.5 meters per second squared. Okay? And that, guys, is how we do problems like this. Variable acceleration, graphs at GCSE, it's actually not that bad. So make sure you like this video, subscribe for more maths content, and like the video I think I said. But anyway, I'll see you in the next video. Nice.